student. In the 11th standard, we learned matrices, some basic operations of matrices and types of the matrices. There are different types. We already learned odd types, and then algebra of the matrices. In the algebra of matrices, addition, subtraction, and multiplication. What is the addition of matrices and subtraction? The only first condition for the addition and subtraction of the matrices is order of two matrices must be same. Then addition and subtraction are possible, otherwise impossible. For multiplication, number of column of first matrix must be equal to number of row of second matrix. Then matrix multiplication is possible, otherwise impossible. These are the conditions for algebra of the matrices. We already learned this part in 11th standard. Now, what we learned in the 12th standard? In the 12th standard, we find inverse of matrix. Inverse of matrix by two types. A first type, elementary row transformation, and second type by adjoint method. And then after, we find or solve application of matrices. Means in 12th standard, the total part is finding inverse and application of matrices. The first, inverse of matrix. For finding inverse of matrix, we must know elementary row transformation. This is the first method, elementary row transformation. And what is the elementary row transformation? Let's understand first the elementary transformation, either row transformation or column transformation. Let's see. Elementary row or column transformation. Consider a matrix A 1, 2, 3, 4. We consider row transformation. Then what is the row transformation? Means of some operations on row. If we consider the first transformation, R1 interchanges R2. R1 interchanges R2. What is the meaning of R1 interchanges R2? Means interchange this R1 and R2. Therefore, this matrix becomes 3, 4, 1, 2. This is R1 interchanges R2. The first operation. We let second operation on the same matrix. Twice R2. What is the meaning of twice R2? Multiply R2 by 2. Therefore, this matrix becomes by these operations. This 1, no change in first row, and here multiplied by 2, therefore 6 and 8. These operations. It is a row transformation. This is the first operation. This is the second operation. Any type of operations. 3. R1 plus 3 times R2. What is the meaning of R1 plus 3 times R2? Means we add R1 and 3 times R2. Multiply this row by 3 and then add in R1. Therefore, matrix A becomes like this. Yeah, 1 R1 plus 3 times R2. 3 times R2. 3 into 3, 9. Then 2 plus 3 times R2. 3 into 4, 12. R2 as it is. 3, 4. Therefore, this matrix is equal to 10, 14, 3 and 4. These are the elementary row transformation. And now let column transformation. In row transformation, we perform operation on row, and in column transformation, we perform operation on column. Now let another matrix 3, 2, 1, 5. If C1 plus C2, like this operation. This is a column transformation, means addition of C1 and C2 means matrix A becomes C1 plus C2, 3 plus 2, 5, 1 plus 5, 6 and C2 as it is. Consider another elementary column transformation. C2 minus twice C1 is subtract C1, first multiplied by 2 and then subtract from C2. C1 as it is now, column first as it is, 3, 1. Now 2 minus 6, because we multiplied C1 by 2. 2 minus 6. 2 minus 6. 5 minus 2. 5 minus 2. 3 minus 4. 1 and 3. This is the column transformation. Now the next and important part is inverse of matrix. Now inverse of matrix. Then what is the inverse of matrix? If any matrix A and another matrix B, if we take its multiplication A into B or B into A, then it is equal to I. Then this matrix B is called inverse of matrix A, and it is denoted by, inverse is denoted by A inverse. Therefore, this relation becomes A into A inverse. A inverse into A is equal to I. This is matrix, inverse of matrix. Then how we define inverse of matrix? Now define in this way. For any matrix A, there is a matrix B such that A into B equal to B into A equal to I. I means identity matrix or unit matrix. Then matrix B is said to be inverse of matrix A. This is the definition of inverse. Now we learn how to find inverse of matrix by elementary row or column transformation. For this, there are some steps. Let first understand the steps in finding inverse of matrix. For any matrix A, we want to find inverse. The first step or some necessary terms. matrix must be non-singular. First condition. Matrix of non-singular, inverse of matrix, non-singular matrix exists. When a matrix is singular, its inverse does not exist. We can find the inverse of singular matrix. But therefore, the necessary condition is that this matrix must be non-singular. Obviously, one condition included in this non-singularity, that is, this matrix must be a square matrix, because we can find the value of square matrix. We can show whether it is singular or non-singular. Therefore, the first condition is square matrix. Another condition is it is non-singular. Then second step, write A into A inverse equal to I. I means unit matrix, identity matrix. It may be 2 by 2, of order 2 by 2, or of order 3 by 3. We can write equal to I. Third step, convert matrix A into I. We convert matrix A into I, means unit matrix. Then how to convert? If, for example, we have a matrix, this matrix A, and we want to find or convert this matrix into unit matrix. The unit matrix of order 2 by 2 is 1 0 0 1. We first convert the first element into 1. Then same column, this element into 0. Then second column, first convert this 4 into 1 and then this 0. Let's go by this sequence. Or if matrix if order 3 by 3, of order 3 by 3, then what is the sequence? First this 1, then 0, then this 0, then the 1. After this 0, this is the 1, then this 0 and this 0, then this 1, and lastly these 2 zeros. This 1 0 0 0 1 0 0 0 1. First this one, then this 2 0, this one, then this 2 0, then this one, and then these 2 zeros. Consider the matrix and convert into this identity matrix by this sequence. If we miss the sequence, then we boomerang, and again there is no identity matrix. So strictly follow this sequence. Then there may be more, 1 or 2 more steps, even though follow it and find the correct answer. Now we find inverse by using these steps we already write here, and now we consider example of finding inverse. Let the example of order 3 by 3 matrix of order 3 by 3, because there are many transformation operations, and our idea easily cleared in one example. Now consider example of inverse. Here matrix A 2 1 3 1 0 1 1 1 1. First decide whether it is singular or not singular. Here we find the value of matrix by converting into determinant, and if we find it is the value of matrix A is 1, therefore it is not equal to 0, means it is a non-singular matrix. Inverse exists. Now start to find the inverse. There are steps. We have steps in the finding of inverse. One by one we follow it and find the inverse. Right. A into A inverse equal to R. A matrix A 2 1 3 1 0 1 1 1 1 into A inverse 1 0 0 0 1 0 0 0 1. We want here 1 first. Then there are many ways to get here 1. Very easy and convenient way. We interchange R1 and R2. Therefore, it becomes there are 1 0 1 2 1 3 1 1 1 into A inverse. Same on other side. R1 interchanges R2. 0 1 0 1 0 0 0 0 1. Now, for getting 0 here and here, from this one, this is our sequence. Don't miss the sequence. For this 0, the operation is R2 minus twice R1, and for this 0, R3 minus R1. Find this 2 0 from this one. Don't find by using any other number, other element. Now, these two operations on both matrices. R1 as it is 1 0 1. Now, this operation R2 minus twice R1, 2 minus 2 0, 1 minus 0 1, 3 minus 2 1, R3 minus R1, 1 minus 1 0, 1 minus 0 1, 1 minus 1 0, A inverse on other side. R1 as it is 0 1 0 0 1 0. Now R2 minus twice R1, 1 minus 0 1, 0 minus 2 minus 2, and 0 0 0. Now R3 minus R1, 0 minus 0 0, 0 minus 1 minus 1, and 1 minus 0 1. Now this first column completed. Now consider the second column. For the second column, 0 is already here, 1 is already here. Only for this one, we here require 0, and which is the operation, very simple operation. This 0 from this one, R3 minus R2, 1 minus 1 0. Therefore 1 0 1, R1 as it is. R3 minus R2 means change in R3 only. 0 1 1. Now 0 minus 0 0, 1 minus 1 0, and 0 minus 1 minus 1 into A inverse equal to. Same operation on other side. No change in R1 and R2. Only change in R3. R3 minus R2. 0 minus 1 minus 1. Minus 1 minus minus 2 is plus 2. That is 1. And 1 minus 0. 1. Now only remains this second column completed by our sequence. Now here we want 1 and then this 0. Here minus 1. Therefore simple operation, R3 multiplied by minus 1. In here 1 0 1 0 1 1 0 0 1 multiplied by minus 1 into A inverse 0 1 0 1 minus 2 0. Here multiplied by minus 1. Here plus 1 minus 1. Here minus 1. Now we get here 1 for these two zeros. From this one, operations are R1 minus R3, R2 minus R3. Then this is equal to here 1 R1 minus R3. 1 0 1 minus 1 0 R2 minus R3 0 0 1 minus 0 1 1 minus 1 0 0 0 1 into A inverse. Same on other side. R1 as it is. Sorry, R3 as it is. R1 minus R3 0 minus 1 minus 1 minus minus 1 that is 2 and 0 minus minus 1 there is 0 minus minus 1 1 R2 minus R3 1 minus 1 0 minus 2 plus 1 minus 2 plus 1 means minus 1 and 0 minus minus 1 means 1. R3 as it is 1 minus 1 minus 1. This is I into A inverse equal to the same matrix, and this same matrix I into A inverse means A inverse, and that is equal to the same matrix, means this is the inverse of our matrix. In this way we find inverse by elementary row transformation. Don't miss the sequence, very important thing here. Sometimes we get 0 from any other operation by breaking the sequence, but it is a boomerang. How it is boomerang? Suppose in this example we get here first 1 R2 minus R3, here 0, but our manipulation finishes. Again here, if here we get here 0, 1 R3 minus R1 minus R3, here get 0, but this 1 finishes, here get 0, means here again boomerang. So don't miss the sequence, that is very important. There may be 2 or 3 more steps by using sequence. Even though use the sequence, means we get a correct answer. In this way we find the inverse of matrix by elementary row transformation. Similarly we can find inverse by elementary column transformation also. Same operation on column. You try yourself, and when we use the column transformation, then consider the sequence of considering rows. Okay. Here A into A inverse is equal to I, the matrix 2 1 3 1 0 1 1 1 1 into A inverse equal to 1 0 0 0 1 0 0 0 1. Yes, when row transformation, here we get 1 then 0 0. For column transformation, here 1. Then this 0 means here 0, then this 0, then this 1, then this 2 0, then this here 1, and then this 2 0. This is the sequence. And sequence changes when we consider column transformation. In row transformation, we learn the problems, and in this way, very easily we can find inverse of matrix. In every example of state board, there is one example of finding inverse, and when there is no example in the exam, this exam is not the board exam. Yes, this is the importance of this type. Again, we have some type to find the inverse, and the next type we'll learn in the next period. And now in textbook there are some examples are given of order 2 by 2, of order 3 by 3, and now some examples of trigonometric elements also, and you try to find the inverse of all these examples in exercise, and after your practice you will be perfect in finding the inverse of matrix. Okay.